Question 3. Okay, so you have to prove 9 to the power of n minus 5 to the power of n is divisible by 4. So the first thing we do is prove it's true for n equals 1. So that means everywhere you see an n, stick in a 1. So 9 to the power of 1, take away 5 to the power of 1, that is 4. And that 4 is clearly divisible by 4, so that's true. Step number 2, assume it's true for n equals k. So 9 to the power of k minus 5 to the power of k, right, is divisible by 4. Okay, so then I need to prove it's true for n equals k plus 1. So everywhere I see an n, stick in a k plus 1. So I need to turn that into something that is divisible by 4. Okay, now, right, okay guys, 9 is very big. Okay, there's more than one 4 in there. So what you do is you split that up into 8 plus 1. Why 8? Because 8 is a multiple of 4. So if it's divisible by 8, it's divisible by 4. Okay, so that's what you break up the 9 into. Here, break up the 5 into, oh, I'm sorry, I missed out a step. So that's 9 to the power of 1 by 9 to the power of k. And this is 5 to the power of 1 by 5 to the power of k. So then, as I say, right, okay, you can split that up into, you could do 4 plus 4 plus 1, but rather we'll just go 8 plus 1, right? Because if 8 is divisible by 4, so that means any number that's multiplied by 8 is divisible by 4. So any multiple of 4 will do, minus, break up this 5 into a 4 plus 1. Okay, by 5 to the power of k. Okay, so multiply out your brackets. Okay, so we have 8 multiplied by 9 to the power of k plus 1 by 9 to the power of k is 9 to the power of k, and here I have 4 by 5 to the power of k, and here I have, sorry, that's a minus, isn't it? Minus 1 by 5 to the power of k is 5 to the power of k. Okay, now they're my bits from my assumption. These are the bits I'm going to put together. So 8 by 9 to the power of k minus 4 by 5 to the power of k plus 9 to the power of k minus 5 to the power of k. So I've just written it in a different order, so these two are beside each other because they're my assumption. Okay, out of these I'm trying to prove it's a multiple of 4, so I'm going to take out 4. So that's 4 times 2 multiplied by 9 to the power of k minus 5 to the power of k, and then I have plus 9 to the power of k minus 5 to the power of k. So the first two are divisible by 4 because they're multiplied by 4, so therefore if you multiply by 4, 4 will definitely divide in. The second two are divisible by 4 because that's what you assumed. Okay, so therefore the whole lot is divisible by 4, so that means 9 to the power of k minus 5 to the power of k is divisible by 4. Sorry, that was your assumption. You just proved that the k plus 1 are divisible by 4. Okay, and then you write your 4 sentences. It's divisible by, or it's true for n equals 1, true for n equals k, true for n equals k plus 1, therefore it's true for all n element of n.